So this week I was trying to explain my students about a little bit of quantum theory for the atom. It's a theory that explains why elements when you hit them, they change colors, they emit a light. It's also the concept behind fireworks and other interesting phenomena that happens in our world. It's also interesting because this book has that theory in chapter 7. This was a different edition of the book that I used in college when I learned chemistry. But in the high school textbooks, they explain this a little bit earlier, like it's in chapter 5 in the Glencoe book. Um, and again, we start explaining about the electromagnetic spectrum first, because we have to understand that first to understand the wave nature of light, and also how some of these concepts apply and help understand us. Um, because light is made of energy, and when an electron moves to a higher orbit, then when they come back to a lower orbit, they will emit energy, and based on that energy, that's why you will see a particular color. They emit a photon of light, and photon is energy. And again, these are concepts that are simplified. Not sure if anybody remember Planck's um, constant and Planck's experiments, and followed by Albert Einstein extension to photons, about photons. And then, of course, the part that I found fascinating is the photoelectric effect. And the photoelectric effect is just the ejection of electrons when light hit a metal, pretty much. And for that to happen, it has to be a specific frequency. It doesn't happen just because. It has to be light has to happen at light has to be of a certain frequency to be able to eject an electron from a metal, from the surface of a metal. But I wanted to show my students something more visual, so I got some solar cells that have been taken out of solar panels that I've been disassembling. I removed pretty much the solar panel, which is the cell that generates electricity. So how this works is like during the day, this is charging a battery that is inside here, and it charges the battery, and then at night when there's no more light, the battery start operating and keeps the LED on, pretty much. So this is the little circuit that you will see inside some of this solar panels. So it's a very interesting, simple circuit. So I've been taking the solar panels, and as you can see here, I already have them here. So I took the solar panels, and I decided to connect it to a momentary switch. And of course, there's a little LED, in this case a LED, and you can see right now that there's barely, this light here doesn't do much right now. Even though it's sunny, the light is not hitting the solar cells too much, so there's not much light being emitted from the LED. No more current passing. I can quickly change that. So this is a regular flashlight that I have. So if you radiate this in here, then you're also going to see the LED brighten up. Now what is interesting to us is like if I take the light away, the intensity and also the wavelengths of the light, the frequency, it just gets reduced. What happens like the light source is not more concentrated, it's becoming less concentrated. So as you can see, it expands. So this expansion means that the frequency becomes larger, becoming larger becomes lower, so the frequency is not as much. So it doesn't have a lot of an impact in generating electricity, in it causing the photoelectric effect on the surface of the solar cell. Although we don't call this a photoelectric effect, we call this an photovoltaic effect, which is similar concept, but it's different because honestly, like I mentioned, photoelectric effect is when light shines on a metal. This technically is not a metal. The material used for solar cells is not a metal, it's a semiconductor, so it's a semi-metal pretty much. but the concept is the same. You're taking the light causes one electron to move out of that particular region and go into the conductivity region that the panel has to be able to travel to the circuit, and then it returns back to the other through the other end to the material, pretty much, and as you can see in here, you can see that without the light there's so much electricity being generated, but with the light frequency increases because it's closer. You can see the brightness of the LED being more, being higher, And again, this is quite an interesting thing that I just decided to show my students, trying to grasp their interest on things and in science, you know. But there's only so much as a teacher that we can do to grasp the interest of the students. But it's again a very cool experiment, and it's something that I just decided to show again to try to show them how so that they can have an idea of how the photoelectric effect may work. It's not the same. The materials and the equipment for that is different. I don't have it, but I do have this past lights, and I have done this previous year where I have removed the solar cells. And I just decided to bring this as a demonstration to show how light with a given frequency or energy, can actually take a electron, pull out an electron out of a material, like in this case, a material made out of the solar that used to make the solar cells, and in turn that can cause and produce electricity to be able to power light. Anyway, hope you like this little demo. So if you have any questions, feel free to ask, and I hope you like the video. Bye.